My name is Willie Smits. I'm the director of the Arsari Enviro Industries and the chief scientific officer. Indonesia still has a lot of forest. It also has a huge amount, 88 million hectares of degraded forest. Indonesia also has about half the world's peat swamp forest, which store 30% of all the carbon, terrestrial carbon on Earth. So if there's any place where you should start saving the world, it is by improving things in Indonesia. The Arsari Enviro Industri Group is a newly established group in Indonesia, which manages about 720,000 hectares, almost 2 million acres of degraded forest lands, and we are converting those lands under the rebuild system into very productive, species-rich forests for a multitude of products, but basically the most important one is biomass-based energy without losing any of the nutrient capital. In our rebuild system, we create mixed forests, which are a mixture of woody biomass, which is then converted to torrefaction pellets, biocoal, and we have a special tree called the sugar palm, which can produce sugar, direct pure sugar, which makes it even easier to go directly to all kinds of other products like esters and diesel oil or jet fuel. You can make anything out of sugar directly. The sugar palm has a huge productivity because of a special photosynthesis, a huge amount of leaves that it can grow on steep slopes. It has roots that go down 6-8 meters in the soil. It never dries out. It can produce so much more, double than what the energy that you can obtain from oil palms. The key is to make use of all the light that you can capture, so to get a closure of that canopy of plants that can convert sunlight into a usable form of energy or food, and then go through a succession where that biomass builds up over time. So the benefit of having the pioneer species in there is that you quickly get your money back, and the combination with suppressing weeds and having a cheaper reforestation for the more valuable longer-term products makes this system a very attractive one, both ecologically and economically. Biocoal is the product of a process which is called torrefaction. It's basically a kind of roasting without the presence of oxygen of biomass, and it converts a wide range of biomass into a very homogeneous, high energy density product, which is completely a replacement for coal. So we do in 30 minutes what nature takes 300 million years. SYNGAS is the product of the gasification of biomass, and when we use our torrefaction pellets as the input for the gasification, we have no NOx, no sulfur, none of those pollutants, and we can recover all the nutrients in that special type of gasification. SYNGAS is a mixture of hydrogen and carbon monoxide, and that can then be used to make a multitude of products. Basically anything you can make from fossil fuels, you can make from SYNGAS. You can go to butanol, ethanol, propanol, you can make DME, you can make plastics, anything. In the process of making the SYNGAS, we also produce a lot of biochar. This biochar can then be used to make again biocoal, or you can put it in the soil to improve the water retention, the fertility. You don't lose nutrients anymore, pH goes up, microorganisms, the soil gets better, so you can grow even more biomass. So that is the great thing about this process, recapturing the nutrients, putting part of the CO2 in the form of carbon for thousands of years in the soil, and the rest of that CO2 becoming carbon to fuel anything really that fossil fuels at this moment provide. This process, removing CO2 from the air, providing a replacement fuel for fossil fuels, in total is carbon negative. This polyculture system provides food, for example cassava, but also fruits from the sugar palm, starch from the palms, and palm heart. Basically, it guarantees jobs and food security and energy and material security for local people while protecting the environment and biodiversity in the forest that consists of these multiple species, including fruit species. If we look at it at an international scale, the enormous surplus of energy produced by this mixed forest needs to go somewhere. It will completely overflow the local market, so that can be transported transport as a high density, energy dense material to the places where it's needed and can then be converted to the products that people need. So torrefaction pellets or SYNGAS can be brought to countries like Japan, which are desperate for environmentally friendly alternatives for the nuclear energy and the fossil fuel-based economy, but also countries like the Netherlands, who are already striving to get to those targets that they have to achieve under the COP21 agreement, and that they can't do without an external source of energy from a sustainable basis like Indonesia. In our model, we are not utilizing any of the good forest. We only go for the degraded forest lands that we rehabilitate. This is an ethical decision that we have taken because we are losing biodiversity, and the environmental effects of erosion and flooding and coral reefs suffering as a result of the mud brought down by rivers is very, very bad for our country. So we have to look at the total picture. Therefore, biodiversity conservation is actually step one in the whole process. Anything that is still good will be left untouched, will be left in the natural condition. Only the degraded forest parts are rehabilitated, but also in a way that it still increases the carrying potential for animals, wildlife in those forests. So we have preservation of original forest, and we create new opportunities for biodiversity to return to the new forests.